A steam turbine is a machine that harnesses energy in the form of steam, converting it into mechanical energy to drive another machine for producing electricity. But how does it work? When under pressure and at high temperatures, steam has thermodynamic potential energy called enthalpy. For example, in a pressure cooker, when the steam reaches a certain level of pressure, it spins the stopper and begins to hiss. When the steam has been heated, it stores energy, as well as the capacity to expand and occupy a greater volume. While the pressure cooker is closed, the steam's energy cannot be released. But when the valve opens, it expands into the ambient air and releases part of its potential. It is this energy that turns the stopper. By channeling this force, we can drive pistons or turn wheels. Alstom applies these same principles to its turbines. The steam is controlled to rotate the turbines by transmitting a mechanical force to them with as little energy loss as possible. The hot pressurized steam arrives in the turbine. It is drawn through to the other end thanks to a cold source. Between the intake and the exhaust, the steam expands. It seeks to occupy a greater volume. To recover the steam's potential energy, it is led through a series of blades, which include fixed blades attached to the body of the turbine and mobile blades attached to the rotor. As the steam passes through the fixed blades, its passage is narrowed to increase its speed. It's a bit like a river. When it narrows, the speed of the water flow increases. It's what we call rapids. Hence, a narrower passage through the fixed blades speeds up the flow of the expanding steam. Thus, a part of its enthalpy is converted into kinetic energy. The steam is directed by the fixed blades towards the mobile blades, which it flows across. These mobile blades are curved to change the direction of the expanding steam. By doing so, the mobile blades are pushed back and begin to move. As these blades are fixed to the rotor, they drive it. Hence, the kinetic energy of the steam is converted into mechanical energy. This mechanical power is gathered by the turbine rotor and transmitted to the generator, which converts it into electrical power. The steam passes via successive rows of fixed and mobile blades. As it moves through the turbine, the steam occupies increasingly more volume. This means that the size of the successive blades gradually increases so as to maximize the conversion of the steam's energy. When the steam emerges from the last series of mobile blades, it is recuperated through a condenser and recycled in the form of water towards the steam generator. Then the cycle begins all over again. There are two types of turbines, impulse turbines and reaction turbines, but that's another story.